Hey guys, in this lesson we're going to take a look at circles in the coordinate plane and specifically equations of circles and how they relate to what you're seeing in the coordinate plane or how to get that out of a coordinate plane. So to start off with, we're going to start with an equation of a circle, and the basic form, the standard form for that is going to be x minus h squared plus y minus k squared is equal to r squared. And this equation should look kind of similar to what you're used to seeing in Pythagorean's theorem, and it is. Because if you look, and we're looking at a circle, and you've got a point right here, HK, that's going to be the center, HK, and then you have a point over here, XY. The equation of a circle is going to describe all of the points that are the same distance away from that XY. So if we want to know the distance from that point to that point, we would use the distance formula. Distance would be equal to the square root of x1, let's have that one be x, minus h squared plus y minus k squared. There would be your distance formula from this point to that point. But in this case, our distance is the radius. Radius is equal to the square root of x minus h squared plus y minus k squared. And whenever we're writing equations, we usually don't have square roots in them, so square both sides. And if you do that, you end up with the r squared is equal to x minus h squared plus y minus k squared. And then again, up in the definition it says hk is going to be your center and r is going to be the radius. Now something to notice is, see how this is r and it's just r all by itself and this is r squared? You're going to have to keep an eye on that whenever we're looking at finding the radius. Okay, if we start trying these out, it wants to know what is the center of the circle. So whenever you're looking at it on a graph, it's not too bad. You just find the point that's in the center, and they're always going to make it a dot, and you just figure out what the coordinates are for that. In this case, the center of the circle would be 5, -2, and there's the center of your circle. Whenever you start pulling it from the equations of the circle, that's where it can get a little challenging. So if you're looking at this one, and if we're looking for the center, we're looking for a HK, and if you look, there's no plus or minus values here, so the center for this one is just going to be 0, 0. Because if we put it into standard form to match that, we would have x minus 0 squared plus y minus 0 squared is equal to 144. If we look at this one has a plus. So if we want to switch it so it looks like standard form, we're going to have x minus, and the only way we can have this be a plus here is to be minus a -5 squared plus, and it's still just y minus 17 halves squared is going to be equal to 144. So if we're looking for our h value here is going to be the -5, and then our k value is going to be 17 halves. So the center for this circle is going to be -5, 17 over 2. And another way to look at it is, you could look at it as you just do the opposite of whatever you're seeing inside the parentheses. So inside this parentheses was a +5. So the x coordinate for your center is going to be a -5. And in this one it's a negative, so you do the opposite and it's going to be a positive. So if we were to write the equation for the circle right here, we would have x, and it's a +5, so we have the opposite of it. So x minus 5 squared plus y minus a -2 squared is going to be equal to, and then the radius is 1, 2, 3, 4, 5 squared. And if we simplify that, we end up with x minus 5 squared plus y plus 2 squared is equal to 25. And whenever you work it backwards, that way you can see how the minus and negative becomes a plus, and that's why you end up doing the opposite. Okay, so that center for this circle right here is going to be negative 5 17/2. This one's going to be 0 0, and that's going to be 5 negative 2. So that's what you do whenever you're looking at finding the center of a circle. Looking at the next type, they could ask you to find the radius or diameter of a circle. And remember, radius goes from the center of the circle to the edge. And then the diameter goes from one side to the other. Through the center. Okay. So looking at this one, what is the radius? We're just going to go ahead and do them both. That way we've got examples of both. So looking at the radius, to get them from the picture, it's just a matter of counting. So there's the center, 1, 2, 3. The radius for this one is equal to 3. And remember, if you're looking for a formula, diameter is equal to 2 times the radius. So your diameter is going to be equal to 2 times 3 is 6. So there's the radius and the diameter for that picture. You could also just count. So 1, 2, 3, 4, 5, 6. There's just 6 for your diameter there. You can also count them vertically, just as long as you're counting straight up, straight down, straight left, or straight right. For whatever reason, whenever I was taught, I was always taught counting from the center to the right, but you can do it whichever way you want. If you want to count up and down, that's fine. Just make sure it's just straight up or down or left or right, and you'll be fine. Alrighty, so looking at the next one, they want the radius and the diameter. So if we're looking at this formula, remember standard form is x minus h squared plus y minus k squared is equal to r squared. So this value right here is going to give us our radius, but this value, r squared, is equal to 25. We're not interested in what r squared is. We want to know what just the radius. To figure out the radius, we take the square root of both sides, and r is going to be equal to 5. So the radius for this one is going to be 5, and the diameter is going to be equal to 2 times that radius, which is going to be 10. Okay, looking at the next one, this is going to give us our r squared value. So with these, you may end up with, like when we do this one, r squared is going to be equal to 45. We're not interested in what r squared is. We want to know just what the radius is. So if we take the square root of both sides, r squared, r is going to be equal to the square root of 45. And part of the directions for almost every single math problem you get is going to be for you to simplify your answer. That is actually not simplified because the square root of 45 can be simplified a little more. And the way you do that is you make your factor tree. So 45, things that multiply together to make 45. 5 times 9, 3 times 3. So r is going to be equal to the square root of 3 times 5. We're looking for groups of 2. So r is going to be equal to the square root of 3 squared times 5. The square root of 3 squared is 3. The square root of 5 is not a nice simple number. So it's just going to be left the square root of 5. So that's our radius. We need our diameter. Remember, we'll write it over here. Diameter is equal to 2 times the radius. And I'm going to use the formula for this one because it makes it a little easier. We're going to have 2 times, and the radius is 3 square root of 5. Whenever you're multiplying things with square roots in them, you multiply the stuff that's on the outside together, and then multiply the stuff that's on the inside together. So you do 2 times 3 is 6. There's nothing here with square roots, so it's just going to be 6 square root of 5 for the diameter. Looking at the next one, r squared is right here. So r squared is going to be equal to the square root of 121 over 4. Because we took the square root of both sides to get the r squared by itself. So r is going to be equal to the square root of 121 over 4. This isn't considered simplified, so you've got to split up the square root to both top and bottom. R is going to be equal to the square root of 121 over the square root of 4. R is going to be equal to the square root of 121 is 11 over the square root of 4 is 2. So there's our radius. And diameter is equal to 2 times our radius. So our diameter is going to be equal to 2 times 11 halves. Make that a fraction. So 2 times 11 is 22 over 2. 22 over 2 is 11. Our diameter is 11. And looking at the last one, they want to know what is the radius and diameter for the circle, still using those directions that we have right there. So we're looking at r squared is equal to square root of 133, and we're not interested in what r squared is. So to undo the squared, we take the square root, man. One more time. So we've got r squared is equal to 133. We're not interested in what r squared is. So to get the r all by itself, we take the square root of both sides, and that'll leave us with r is equal to the square root of 133. And if you try to simplify this one, it doesn't actually simplify down. You're just left with the square root of 133. To get the diameter, we do 2 times the radius. And there actually isn't any other way to simplify that one down either. So that's another possibility of what you could get for the answer. So there's just several different examples of how to find the radius and diameter of a circle. Okay, and the last group that I have for you is graphing circles in the coordinate plane. So looking at this first one, in order to be able to graph a circle, you have to have 2 things. The first thing you've got to do is figure out your center. And if you remember from our definition, the center is the HK values. And then the second thing you have to know is your radius. And that's just your R value. And you're going to get those from the original equation, the standard form of the equation of a circle that we saw before. So if we're looking at this one, we've got x squared plus y squared is equal to 81. So if you're looking at standard form, x minus h squared plus y minus k squared is equal to r squared. There's no plus or minus in parentheses with the x and the y. So our h value, if we were to expand this out, we have x minus 0 squared plus y minus 0 squared is going to be equal to 81 is what we've got there. So if we're matching up the parts that are similar, h is equal to 0, k is equal to 0. So our center is going to be 0, 0. And then our r squared is equal to 81. Take the square root of both sides, and our radius is going to be 9. So to plot that, you go to 0, 0. And then you count out 9 in all 4 directions, up, down, left, or right. So there's 9, 9, 9, 9. And this is how you do it if you're plotting by hand. I believe if you're plotting on the computer, you plot this point right here and then click on one of those 4 dots right there, and that'll give you your circle. Okay, so there's the circle for that one. Looking at this next example, if we're looking at our x minus h squared plus y minus k squared is equal to our r squared. We don't have anything to match up with our x, so it's like we have x minus 0 squared plus y minus 6 squared is equal to 16. So if we're matching up here, so pretty much anytime you see either x squared or a y squared, whatever value that is, the center for that one is going to be 0. Looking at this one though, we have a value that matches up with k, and that's going to be 6. So remember, you do the opposite of whatever you see in the parentheses. So we've got a negative 6 here, so our center is going to be on 0, 6 there. And then to be able to know how wide or what the radius of our circle is. We've got to look at that part right there. So second part, looking at the radius, r squared is going to be equal to 16. Take the square root of both sides, and it'll leave you with r is equal to 4. So 1, 2, 3, 4. 4, 4, 4, and then there's your circle there. Looking at the next one. They give us x plus 4 plus y squared is equal to 36. And again, when we're graphing a circle, we need two things. We need the center from the HK, and then we need our radius, which is just the r value. So if I'm looking here, I've got h value is a -4, and from that one the k value is 0, and then the r value, that's our r squared, is going to be equal to 36, so r is just going to be 6. So our center is going to be, find a spot to write it, put it right here. Center is going to be h is -4, 0, and our r is going to be 6. So I've got -4, 0. Cut out the radius 6. So there's a couple examples where the x value is the only one that, the h value is the only one you have a number for, and so therefore it's only going to be on the x-axis. And here's one where you just have a y value, and so therefore your center is going to be on the y-axis, and then here's one at the origin. The next couple are going to move around to different spots and kind of show you how different things work. So if we look at the formula with this one, x minus h squared plus y minus k squared is equal to r squared. So for matching here, this matches up nicely. We've got the -3. This one would have to be a minus a -5 in order for it to be a minus like the formula there. So then our center is going to be 3, -5, and then the radius is going to be equal to 5. So do the opposite of what you see. So -3 is a positive, and then the +5 is a -5, and the radius for the circle is going to be 5. So if we graph this, we've got 3, -5, and then the radius is going to be 5. Looking at the last two, they do give you some examples wherever you have decimal spots and have to graph using those decimal spots. But it's the same exact process. It doesn't change. You just have to put it in the middle. So looking at first, we need our point. That comes from our HK values. So you do the opposite of what you're looking at. So we have -3.5 and then +4. And then our R value, take the square root of that one. Our radius is going to be 4. So -3.5. So you go over 1, 2, 3, and halfway. So there's your -3.5, and then up 4. 1, 2, 3, 4. So there's the center there. Counting out the center isn't too bad. It's counting the radius that can be kind of messy whenever you're counting it, whichever way is the half. So whenever you're counting the radius here for this one, counting up isn't bad. 1, 2, 3, 4, there's that one. 1, 2, 3, 4, there's this one. Now whenever we count over, we can't count here because that's only a half. So we have to count the halves every time we go. We want one of the wholes. So there's 1, 2, 3, 4 for the radius. 1, 2, 3, 4 for the radius to the left. Connect those points. And there's the circle. And then looking at the last one, they want us to graph the circle. In order to graph the circle, you have to have two things. First thing you have to have is the center. You get that from your H value and your K value. So looking at this one, h, remember to do the opposite of what's in the parentheses. So opposite of a positive 1.5 is a negative 1.5. And then opposite of a positive 2.5, negative 2.5. And then the second thing you need is the radius, and the radius comes from that value right there. That's our r squared value. And then the square root of 1 is 1. So if we count that out, we've got negative 1.5, negative 2.5. And our radius is 1, so over 1 that way, up 1 that way, over 1 that way, and then down 1 that way. So connect those 4 points, and there's the circle. So there's your several different examples of how to graph a circle in a coordinate plane given the equation in standard form for a circle. And then we did several examples where we were looking to find the radius and diameter of a circle. And then finally we started with finding the center of the circle, whether we're given just the picture or given an equation to work with. If you have any questions, be sure to write them down on the paper and ask whenever you get to class.